Hello viewers, in today's session we are going to discuss another important problem from limits, and here we have to evaluate this limit, that is limit n tends to infinity. Here we have 2 raised to n plus 5 raised to n, and the whole power is 1 over n. So let us call this limit as L, right? Now we can rewrite this limit as limit n tends to infinity, and here we can take 5 raised to n common from 2 raised to n plus 5 raised to n. So we have here 2 raised to n divided by 5 raised to n plus 1, and the whole exponent is 1 over n, right? Now we can rewrite this limit as limit n tends to infinity, 5 raised to n. Now this 1 over n may be distributed over these two terms. So we have 1 over n, then we have 2 raised to n, 5 raised to n plus 1 raised to 1 over n. Now we have limit n tends to infinity. This n and this n get cancelled. Here we have 5, and here we can now write 1 plus 2 over 5 raised to n, and here we have 1 over n, right? So now we can take this 5 in front of this limit notation. So we have 5 limit n tends to infinity, and here we have 1 plus 2 over 5 raised to n raised to 1 over n, right? Now see this limit. Now here we have two functions. The first one may be taken as f1n, and we have 1 plus 2 over 5 raised to n, and the second function, which is this exponent, it may be taken as f2n, and we have 1 over n. So now our limits, it becomes a limit n tends to infinity. Here we have f1 of n raised to f2 of n, right? So whenever we come across with these kind of limits, we first take this function as f1n. The variable may be n or x, and the second function may be treated as f2n, that is the exponent. So now let us find out the limit, that is limit n tends to infinity f1 of n, right? And let us call this limit as lambda. So we can now write lambda is equal to limit n tends to infinity, and here we have 1 plus 2 over 5 raised to n, right? Okay, now let us consider this fraction, that is 2 over 5. Now 2 over 5 is 0.4, that is less than 1, right? So when we take the powers of 2 over 5, then the fraction, that is 2 over 5 raised to some power, is less than 1, right? So as we increase the power of 2 over 5, then this term, that is 2 over 5 raised to n, where n tends to infinity, then this fraction 2 over 5 raised to n tends to 0, because 2 over 5 is less than 1. So as we go on increasing the powers of 2 over 5, then this entire term tends to 0 as n tends to infinity. So now here we have 1 plus this term is now 0, so we have simply 1, right? So lambda is equal to 1. Now let us find out the limit of this function, that is limit n tends to infinity f2 of n. So here we have a limit n tends to infinity, and f2n is given by 1 over n, right? Now see, as n tends to infinity, as n becomes large and large, then 1 over n tends to 0. So here we have 0, right? So let us call this limit, that is the limit n tends to infinity, f2 of n is equal to mu, right? So our mu, that is the limit n tends to infinity f2 of n, so mu is equal to 0. So now consider the general case, right? Suppose we have to evaluate the limits of this form, that is limit x tends to a, and here we have f1 of x raised to f2 of x, right? And if we take limit x tends to a, f1 of x as lambda, and limit x tends to a, and here we have f2 of x, and this limit is taken as mu, then the value of this limit is equal to suppose this limit is L, right? Then the value of this type of limit, where limit x tends to a, f1 of x is lambda, and limit x tends to a, f2 of x is equal to mu, and provided this lambda must be greater than 0, right? So in this case we have lambda is equal to 1, and this is greater than 0. So in this case the value of this limit L can be directly written as lambda raised to mu, right? So this is the formula for finding out the values of limits of this type, that is limit x tends to a, f1x raised to f2x. We take lambda as this limit, mu as this limit, and here the condition is that lambda must be greater than 0, right? So then the value of this limit is given by lambda raised to mu. So in this case the variable was n, and we have this limit as lambda, this limit as mu. Lambda is 1 and mu is equal to 0, and here lambda is equal to 1 is greater than 0. So now the value of this limit is given by here we have the factor 5, and this limit is given by lambda raised to mu, and here we have 1 and mu is 0, so this is 5 times 1, that is equal to 5, because 1 raised to 0 is equal to 1. So viewers, due to this result, the value of the given limit L is equal to 5, right? And remember, here we have taken x tends to a, and here we have n tends to infinity, right? So using this result, we can easily find out the values of these type of limits, provided this limit, that is limit x tends to a, f1 of x, that is lambda, it should be finite, and it should be greater than 0.